same
Because
side.
it proves the point.
Okay,
You
proves the
can see that
point.
every circle is similar in that.
Okay, so you can see that every circle, right? Versus if we just use one circle, it wouldn't really say much. Right? Because a ratio has to do with understanding that it applies in every situation. Right? Okay. So now that we know that pi is the ratio between the two, talk with your partner and see if you can come up with a formula for the circumference of the circle. Okay.
Pi r squared.
Yeah.
Talk with
Oh,
your
that's the
partner.
error.
Talk with your partner. Talk with your partner. That the one?
Yeah, that's the.
Matthew, with your partner.
7 times 5 for sure.
Yeah. That's the area.
The area. Oh wait, no, it's not the
Don't remember it. Try and think about it in terms of the ratio.
Just diameter
I just
We decided on pi.
Matthew,
What did
is
you
your
say?
streak?
Radius.
Yeah,
Wait, Matthew, what'd you do?
Wrong. Would you appear
it's on your back.
It's on your back.
Pi r squared.
It's a lower.
Matthew, what happened?
What is it? Times. Are you sure it's squared? That's the area. What do you?
Well, we're looking for the area.
I might get mixed up.
We haven't talked about area. I don't know if I said
So we
anything
just
about
need
area.
the circumference. I
Maybe
feel like
it's not pi r
it's,
squared. But it's like.
I really feel like it's pi times the diameter.
No, I think it's just pi times the area.
Why would you
Takes two
divide
pi
it
r.
1.5.1. Oh, then
Why would you divide it by 2?
Yeah.
No.
Wait, where'd you get 2?
Yeah,
Two
these are just pi
Yes.
times
Like,
diameter.
let's do 9
I'm pretty sure you're right.
That's it. Let's go Kelsey, I see.
Where's the pi button? 28.278. That works on that one. 14, yeah, I think it's that. It's 44. Oh, it's close. It's one away though. Let me get my measurement. So like, it works for you.
I don't know.
So, if we know that pi is the ratio of the circumference to the diameter, can we algebraically figure out what the circumference would be?
Yes, we can.
How do you do that?
We can multiply by the diameter.
Good. Multiply both sides by the diameter.
And then you
And
get
we would get the circumference is equal to.
the diameter times pi.
Very good. Okay. Now, pi is a very interesting number. Okay. A, it's irrational, which means it goes on forever, right? Without repeating, which is the crazier part. So when we first started looking at pi is a pretty old concept.
Is that 2?
What it's, oh no, sorry.
At one point, it's gonna repeat.
My fault. So, pi is a pretty old concept. People have thought about this ratio for a long time. But until the invention of computers, we didn't know how long pi went without repeating. This is the first million digits of pi.
That's a lot of them.
Let that sink in for a second. Million digits of pi. And it doesn't repeat or stop
It's going to at some point.
forever.
Coach Basone?
Huh? I don't know. That's the cool part. Yes.
Didn't some girl like recently extend it to like 30 trillion or 30 billion or something?
Yeah, there's a lot of digits now.
Like it's like a world record or something.
Yeah.
So that's 1 million.
Yes.
Well, what is the point of pi?
The point of pi is that it matches up with the diameter and the circumference, and we'll also see what else it matches up with. So,
At
The
some point,
first-
it's gonna repeat. At
the
some
first note that you're going to put in is the circumference. Okay, the formula for what a circumference of a circle is.
you were right.
So now, with the advent of pi, we can use the diameter of a circle to find the circumference, which is helpful with a lot of things. For example, have you ever seen somebody walking? Maybe not. Have you ever seen somebody walking around and it's got a little stick thing? It's got a wheel on it, and the wheel spins, and they're measuring distances.
Yeah.
Okay. Well, now that I know I can find the circumference exactly, I can use how many rotations that wheel takes. Will tell me I've gone one circumference length, right? So, for example, if the circumference of the wheel was 5 feet, and the wheel, which would be a big circle, and the wheel turns once, how far have I gone?
5 feet.
5 feet. Right?
Where are we supposed to go from?
There you go. That's the circumference.
Oh, we're supposed to put it out.
Yeah. Right click. You guys remember seeing this slide? Where I talked about the difference between arc measure and arc length?
Sort of, kind of.
Kind of.
A little bit of deja.
Okay. So now that we know what circumference is, right? Now that we know what circumference is, what if I want to talk about just a part of that circumference? Right? I just want to talk about this little section. Okay? That's what we call the arc length. Okay? That's what we call the arc length. Now remember that the difference between the arc measure and the arc length was the arc measure is this angle. The arc length was the distance from A to B. So the arc length is the distance as I walk along the circumference. Okay, as I walk along the circumference, that is my arc length. Okay. Now the question is, how do I figure out what the arc length is? How do I figure out what the arc length is? Well, the one thing that I will know, the one thing that I do know is arc measure, right? We've talked about arc measure. Okay. What is the biggest arc measure you can have in a circle?
360.
60, right? The whole measure around the whole circle is 360. So I'm going to make a proportion. I'm going to make a proportion. Okay? So if 360 is my total, I'm going to put whatever this angle is, whatever my arc measure is. And what do you think the whole arc length the maximum arc length of this circle would be?
360.
Not 360, arc length. Arc length,
Oh.
distance. Not 180. What would the total distance around the circle be?
DR.
It's the circumference, right? Or the diameter times pi. Or circumference. Okay. And I'm just looking for that part, right? So I have part over whole, so I'm going to put part over whole. This is me my arc length. So now, if I want to figure out the arc length, what? No, it's a D. It's a D. And so now if I want to figure out arc length, all I need to figure out is the arc measure. Is the arc measure in the diameter or the arc measure in the circumference. Right? So if I just want to find a section or a part of the circumference, I can do that now. I'm just going to take the part, the arc length, put it over the whole arc length, which is my circumference. And that's set that equal to the arc measure, which is my angle, over the whole arc measure, which is 360. And I know it's not cool to show it, but this is what's going on in your head right now. Mind blown.
Where did you find that?
Very cool.
What is that from?
I don't know. Just think about all the applications of something like this. If I'm trying to find distances around ponds, or I'm trying to find a certain distance around a track, or any type of arc that we would have. Any type of arc that we would have, I could find the length of that arc based on the circumference of that whole circle. Okay?
Let's measure my
So when you think about all the technology that we have, whether it's the Apple Watches or anything on your laptop or video games and programming, things like that, the ability to measure an arc is vital to being able to provide some of those applications. So it's pretty cool. That's what I'm trying to say. I had to quit playing with string. Right click, we good? So, if we know the arc length, my question is, why do we mess with angle measures at all? Why don't we just talk about arc length? And yet? Because, for example, it'd be easy to say that this arc length here, right, is 1 radius, right? The length of that arc is the same as the radius, so therefore that's 1, right? That would be one arc length, 1 arc, right? Now we could have 2 arcs and 3 arcs and 4 arcs. Why say degrees? Why are there 360 degrees in a circle? Anybody know? Or you just got told that? You just got told that, right? There's actually no real reason mathematically for it to be 360 degrees. Besides the fact that 360 is a really nice number. It's divisible by a bunch of stuff. But there's no real reason for it to be 360. The actual mathematical way we should think about these arcs is based on the distance of the radius. So if this arc length is the same distance as the radius, this is 1. So how many radii do you think it takes to fill up half that circle?
3.
3-ish, right? Okay, 3-ish. It's this one, isn't it? Yeah, 3-ish. So when we talk about the arc length being equal to 1 radius, that's what we call 1 radian. Okay, 1 radian. Okay, so stick with me. So radian is not, don't think of this as anything too complicated. We're just, instead of describing an arc based on angle measures, we're describing it based on arc length. So 1 radian, which is describing this angle here is 1 radian, okay, means that the arc length associated with that angle is equal to the radius of that circle.
So how do we determine if it's radian?
Good question. We'll get there. So, you guys said about 3 radians in half a circle, right? About 3. Kind of looks like that. Well, in half a circle, we have 1, 2, 3-ish, right? There's a little bit extra. That little bit extra. How much do you think that little bit is?
0.14, etc.
Cooper, why did you say that?
Because I made the connection in my head with pi and
Yeah.
the circle.
Because pi has a lot to do with circles, right? Okay. Pi has a lot to do with circles. So there's actually pi radians that fit in half a circle. So 180 degrees is equal to pi radians. Now, going back, this is probably why people started using degrees instead of radians, because when I'm teaching middle schoolers about degrees, if I were to tell them that half a circle is pi radians, they would look at me with very blank stares. So degrees is a little bit easier to comprehend there. Okay. So when we go to look at transforming degrees to radians, okay, degrees to radians, we take our degrees and we set up a proportion. Shocker. It's always about proportions. We set up a proportion. So we set my degree measure over the total and my radian measure over the total. If half the circle is pi radians, then the whole circle would be 2 pi. 2 pi radians, right? So, if, oh no, wonder what this. Yeah. So if this is, here is 45 degrees, okay, and I want to turn 45 into radians. I want to figure out how many radians is 45 degrees. Okay. I would take 45 over my total, 360, and set that equal to the radians, which I'll use a big R, over the total number of radians, which is
2 pi.
2 pi. With me? So, 45 divided by 360, and we're going to multiply 2 pi to the other side to get our radians. So when we multiply 2 pi to the other side, we get R equals 45 times 2 pi divided by 360. Right? Which would be equal to 2 times 45 is 90, so it'd be 90 pi over 360. Can I simplify that at all?
Yes.
Yeah. By what?
30.
30.
30, right? 30? We'll start. 30
Or 90.
or 90.
Yeah, 90.
Oh, it's 360.
Divisible by 90.
90?
Oh, it is.
90.
Let's do 90. So on top, if I divide by 90, the 90 goes away, so I get pi on top, and 360 divided by 90 is 4. So 45 degrees is the same thing as pi over 4 radians. Okay. Question? You sure?
So we like pi by 4.
Yeah.
You get
To get a really long decimal, or you just write pi over 4. Radians are a lot nicer when we start dealing with those tangent functions next year. Okay, yeah.
Do you want like the answer? Do you want the decimal form, or do you want that?
Good question. I want this. This is our exact answer. Okay. So whenever we're dealing with radians, we want it exact. Right? Yes.
So 4 isn't, like, what is 4, like, in the problem?
What do you
What
mean?
is that, like, how did you, is that like the number of radians or something?
Yeah, so the number of radians would be the really long decimal that you get when you divide 4 by, or pi by 4. That would be the number of radians, but instead of having you say the really long decimal every time, we just say it's pi over 4 radians.
And also another, if I can just add this, it's a fourth of pi.
Yeah.
So when you think about taking a fourth of only 3 point something, it's less than 1 radian.
So if we go back to this one, a fourth of pi, if this is 1 radian, it'd be less than 1, just less than 1 radian, so it'd be somewhere in there. That makes sense? So it'd be a little bit shorter. So the arc length would be a little bit less than 1 radius. Think about it that way too. So, if this 45 degree angle is pi over 4, what would 90 be? What am I doing to go from 45 to 90?
Multiplying by 2.
So what do you think I do to go from pi over 4 to whatever the radius or radians of 90 is? Multiplied by 2. So instead of 2 pi over 4, I just get reduced pi over 2. Right? So if I wanted to put another 45 on there, what would that be?
Would it just be pi?
Hmm?
Does it just be pi?
It wouldn't just be pi, because we know that 180 degrees is pi, right? Remember that's what we talked about when we filled this in? 180 degrees is pi.
So pi over 1.
No, that would still be just.
So if this is pi,
Um,
let's do it this way. Let's count.
Fourths.
We have a fourth, a fourth, a fourth, a fourth. So if this is 1/4, this is 2/4, this would be
3/4.
3/4. So 3 pi over 4.
Oh, this one is 2 because it's 2/4, and that's half.
So then what would another fourth be?
That'd be
So we have 1/4, 2/4, 3/4, 4/4, or pi, and this would be
5/4.
5/4.
So 5 pi.
Then what would
6 pi over
3 over
6 pi over 4 or
3 pi over 2.
3 pi over 2? 7 pi over 4. And the last one?
2 pi.
2 pi, right? Because the whole circle is
2 pi.
2 pi.
Okay. Why not? So the reason radians are easier when we do math, okay, is because they match up with our sine, cosine, tangent function a lot better. In the sense that you'll learn a couple different formulas to match this up with radians. But also, when we use radians, we can combine like terms a little bit easier, especially when the problems get really big. Okay. And it helps us deal with arc length. So remember, you can count by fourths as we go around the circle when we're talking about 45 degrees. Okay. So, moving on to area of a circle. Okay. Remember in last class we talked about what we did with perpendicular measures. Okay. For example, a rectangle, the base and the height were perpendicular, and so we did what to them? Multiplied them. A triangle, the base and the height are perpendicular, so we multiplied them. Parallelogram, base and the height were perpendicular, so we multiplied them. So if I have two perpendicular radii, what do you think I'm going to do to them? Multiply. But I need to figure out how many of these squares actually fit into my circle. Because notice, if I just multiplied the two radii, I'd get the area of this square, right? Okay. How many of those squares fit into my circle? 4, kind of 4, but remember there's this little bit on each square that's missing, right?
Probably pi.
So it's probably pi. So it's a little bit less than 4. It's actually 3.14159, blah, 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 whatever. So it's actually pi. Pi of those squares. So we found how many of those squares it is. Find the area of that square, multiply it by how many of those squares we need, and that's how we find the area. That's why pi is really cool, because it keeps coming up over and over and over and over again. And we don't know why. It's just magic. Because the cool part about pi is that if the area formula uses pi, it's the same pi as the circumference formula. And for that to be the exact same pi, that means all of those millions of digits has to be exactly the same. So it's not just like 4 or 5 numbers match up, it's millions, billions, trillions of digits match up perfectly in both of these formulas. Perfectly. Just by nature. Nobody made this up. This is just natural. Yes?
When we're giving the answers for these, you want like the long decimals?
No. So, when we do we'll do an example in a second. But when we do an example, we'll use pi. So an area would be, if the radius was 3, the area would be 9 pi. Cool? So, just like when we talked about circumference and we wanted to find a chunk of that circumference or a piece of that circumference, and that was the arc length, what if I wanted to find a piece of the area? Okay. Well, it's called the sector area. Okay, it's called the sector area. Sector area. So think of this like a pizza, right? We have a big pizza, and the area of that pizza is pi r squared. Okay, but if I just want to figure out how much the area of one of those pieces is, that's what we call a sector area. Okay. So we're going to do the same thing we did for arc length. We're going to set up a proportion of our sector area over the total area, which is the formula for our area, the circle. And we're going to set that equal to our arc measure, which is the degree over the total. So, if, for example, this arc measure was 45 degrees, okay, and the radius was 3, I would set this up as sector area, we'll call it SA, is equal to pi times 3 squared equal to 45 over 360. Right? So all I did was my sector area, or the area of this blue part, divided by the whole thing, the area of the whole thing, because that's my radius. Divided by the area of the whole thing is equal to the arc measure here, divided by the total arc measure. Okay. So now if I multiply to solve for sector area, I would get 45 times 9 pi divided by 360. Yes. Okay. And then reduce from there, and you get, you divide.
1.5.
No, I need the exact answer.
405
It's not pi. What's 9 times 45?
405.
405. And then now we need to reduce. So you can divide both of those by 9.
9 over 8.
So that would be the sector area.
If the angle is 45.
If the angle is 45 and the radius is 3. Cool. So you just gotta set that proportion. Okay.
So you want it in terms of pi.
Yes. 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 And once again, I know it's not cool, but I know this is how you would have reacted if it was cool to like math.
Bro, math is fun.
Isn't that from like?
I think it's from
Got
American
Talent.
Idol or something, yeah. Something like that. We good?
Yes, sir.
Cool. So, a couple examples, just make sure we got it down. Okay. So in your notebook, try this example out for yourself. We're just looking for the area of this circle.
In terms of pi,
In terms of pi, yes. In terms of pi. An exact answer for the area of the circle, yes.
64 pi.
Okay. Wait for everybody else.
It's not.
It's not. Hint, hint, he's wrong.
that's the guy.
We're trying to find the area.
Exact answer for the area, yes. Cooper,
Yes.
what'd you do?
I got. So that's the diameter there.
That
So
is the
I
diameter.
divided that by 2, so I had the radius, which was 4. and then the answer would be 16 pi. So you gotta square that radius as our formula says.
Thumbs up if you got it. Feel pretty good?
I wonder how well that picks up.
Our next one. Find the sector area for the blue part. The blue part.
Wait, for the blue part?
Is there like a button for pi so we don't have to like use this number?
It's
There
the
is a
section
button.
of- But if you're gonna leave it in terms of pi, you don't really need it.
So can we just multiply these two numbers? Okay.
And then divide by it. You can cross multiply it.
Yep.
Multiply those two and then divide by that.
Okay.
But remember, we gotta leave it in terms of pi because I want an exact answer.
Okay.
I just gotta reduce. You can, yeah, or you can divide these two.
Are you gonna tell me the answer? Or?
Yes.
Yeah.
Okay, hold on.
Matthew, is this what you got? Okay, yeah.
Marianne? There? You got it? Alright. Marianne, what'd you get?
54 pi.
54 pi. Okay, thumbs up if that's what you got. Okay, looks like most people agree with you. Alright, Marianne, how'd you get that?
I did S
Okay, so our surface, or our sector area, not our surface area.
over pi times pi times 9 squared.
Good, where'd you get 9 from?
Oh, it's a radius.
It's the radius, good.
And I got 240.
240, where'd that come from?
It's like
Good, it's the arc measure. Notice, this is talking about the blue arc measure. Okay. If I were to tell you that this angle here was 240, would that be equal to my arc measure?
Yeah.
Why?
Well, because the same.
Right, they're the same, but remember, from last chapter, the central angle is equal to the arc measure. Remember that?
Yeah.
Okay, so we gotta still remember those things from last chapter. Alright? Okay. So you got 240 over what?
360.
360. Cool. And real quick. So from here, I'm gonna reduce this side first before I start multiplying, just so my numbers become a little bit smaller. So I know I can get rid of these zeros, right? And then I can divide by 6.
Yeah.
So I get 6 and 4. And I can divide by 2, so I get 2/3. So now I get SA over 81 pi is equal to 2/3.
Uh-huh.
Then what'd you do, Marianne?
she didn't redo.
She did what?
She didn't redo.
Oh, that's fine. You just what'd you do with this from here?
I did SA equals 240 times pi 1 over 360.
Right. So you multiplied both sides by the pi over 81. So let's do the same thing here. So we get SA equals 81 pi times 2 over 3. And then 81 times 2 is 162. And then 162 divided by 3 is 4. That's a pi. Cool. Very good. Very good. Very good. Alright, I think there's one more. Yep. Alright, find this angle measure in radians. Find this angle measure in radians.
So do we know if that's from the center of the circle or not?
You can say that this vertex is the center of the circle.
Okay.
Can I find that? Yeah. Can I find it?
Just for purposes of not being self-assuming. You can do that with the center. Some people do.
We don't
I got 2 over 6.
There's just like.
pi the rate reduces.
Yeah, but the capital SA is connected.
Marston, what'd you get?
Okay, radian equals pi over 3.
Radian is pi over 3.
Yes.
Thumbs up if you agree. Cool. Awesome. Good job. Yep, pi over 360 is pi over 3. Yes. Okay. So we're going to set it up 60 over 360. And that's equal to the radians over 2 pi. Because 2 pi is the total number of radians. Right, the whole thing's 2 pi. And so then I can reduce a fraction, so I get 1 over 6. Cross multiply, or multiply both sides, and then I get 2 pi over 6. Alright, last. Don't wrap it up in.
Second terms.
What?
Nothing.
Find the arc length. The 13 is the radius.
Pi over 3.
Reduces first.
Okay,
think I'm just
Wait.
giving you a little warning.
Okay.
Is diameter times pi.
Yeah.
I'll make sure I can-
So the arc length is, that's what we're trying to find?
Yes.
Okay.
Where's the pi button? Where is this pi button?
It's, the up
Oh,
arrow.
yes.
You just have the second up arrow. The arc length is like, like a distance in the arc measure is degree.
But it's in the right?
No, they're not the same number. Because like arc length would be the 13 inches, and then the arc measure would be 115.
299 pi
Except
over
13 inches
36.
is not the arc length, that's the radius, I think.
Exactly.
Can't tell. I'm struggling with this one. How did you get 26
Yeah,
pi?
over 26.
Oh, because diameter is 13.
JP?
I got 299 pi over 36.
299 pi over 36. Is 299 not going to 36?
No.
No.
299 pi over 36. Thumbs up, that's what you got.
We did.
I didn't.
Yeah, we do. Alright, so when we set up our proportion, we have our arc length over the total arc length, which is the circumference. Remember, the circumference is the diameter times pi. So if our radius is 13, our diameter is twice that, 26. And we put that over our arc measure, over the total arc measure of the circle, which is 360. And now we cross multiply, so we get 115 times 26 pi divided by 360 equals. Oh wow.
That does not go down easily.
It's NG.
Or,
Jake?
Mhm.
What I said?
Yeah.
Then we just multiply everything. Alright. 0 to 5. Okay? 0 to 5. How confident, how comfortable do we feel with arc length, arc measure, radians, area, circumference? Okay. Hold on. Give me your number first.
Yeah.
Maybe a 3.1415.
1.4.
Alright. Not too bad. Okay. Yes, second.
So we're gonna have to remember all these formulas for the test?
Probably. No.
I reduced.
Probably not.
Oh, okay.
Yeah, that was having just a little bit out.
Yes,
Like, this is a lot to
26.
remember.
That was a 5.
Oh, you're changing your answer.
Well, I.
Luke.
Yes.
Well,
what is the ratio of pi? Right, let's start there.
The ratio
What's
is
the ratio of
the circumference divided by the diameter.
Good. Good. Megan? Square. Good. And why do we square pi? Why is it pi times pi?
Because that's the circumference of the circle.
It's not the circumference. Remember if we go back to this, because they're perpendicular, right? Just like all the other shapes, if it's perpendicular, we multiply them together. Okay. So, Grace, can you think of one way that finding the area of a circle might be useful?